we're talking about the triangle inequality theorem. Okay? So the triangle inequality theorem helps us decide if we had three lengths of some material, wood, PVC pipe, pieces of string, could we create a triangle? So you'll see here we have triangle PQR, and it's obviously a triangle because each of its vertices, they connect up. It's a closed figure. But sometimes maybe you would have, maybe you're trying to build something. Maybe you have three lengths of wood, and you're trying to decide, could I make a triangle without having a saw? Maybe my saw is out of commission. Okay, and so you need to be able to tell, could I make a triangle without actually having to just test them out? Okay, so for example, if these were my three lengths of wood and I tried to lay them out, I can really easily see I can't just make a triangle without being able to cut one of them. All right, this endpoint of this line segment here does not meet up with this endpoint of this line segment here. And so there is no triangle because it's not a closed figure. Okay, so it's not always as easy to see as that. And sometimes we can't lay it out. Sometimes we don't have the materials with us. Somebody just wants to know on the fly, could you make a triangle out of this? All right, so we have this theorem that helps us decide that. And this theorem says if you add up any two sides of the triangle, okay, so for example, we're going to add up PQ plus QR. Those two sides of the triangle added together have to be bigger than the third side of the triangle. So we added PQ and QR, so the third side of the triangle is PR. So we have to add PQ and QR, and they have to be bigger than PR. Okay? And that'll work for any three sides, if you add up any two sides of the triangle. So we could also have added PQ and PR, and those two have to be bigger than QR. Or we could add QR and PR, and those two sides have to be bigger than PQ. Okay, so we're going to be using this rule, and we're going to try an example. So what if I gave you three sides of a triangle? So you have one side is 6.8, one side is 7.2, and one side is 5.1. And I'm going to go ahead and color code these so that you can follow my notes a little bit more easily. And it's always helpful to color code in your notes also. So we're going to have three equations we have to check. You have to check all three of them because sometimes like the first two will work and will look okay and the third one won't be okay. So you have to check all three. So we're going to start here and we're going to say, okay, 6.8 plus 7.2. You want to know what that equals. And we're going to have 7.2 plus 5.1. Okay, we want to know what that one equals. And we're going to have 5.1 plus 6.8. Okay. And I think it's a really good idea to go ahead and set up your three equations before you start the actual addition and subtraction, or sorry, not subtraction, addition with all of these. I think it'll help you make sure that you don't make any mistakes, and will just be easier in the long run. Okay, so 6.8 plus 7.2 is 14. Okay, and that was this side of the triangle and this side of the triangle, and we want to know, is it bigger than this side of the triangle? Okay, so is 14 bigger than 5.1? Yes, it is. Okay, so that side looks good. Okay, so now we're going to check the next one. So 7.2 plus 5.1 is 12.3. Okay, and we used 7.2 and we used 5.1. And so we want to know, is 12.3 bigger than 6.8? And again, yes it is. So that one is also good. Looking good so far. Okay, erase those. Okay, the last one, 5.1 plus 6.8 is 11.9. And we want to know, is that bigger, these two, is that bigger than 7.2? And yes, it is. So their question about can these three sides form a triangle is going to be yes, they can form a triangle. Okay, because all of these little tests that we just ran up here, because that's really what we're doing, is we're testing out each of those side measurements, they worked out and they followed the inequality, and so that means that those would form a triangle. Okay, so what does it look like when it doesn't form a triangle? Well, let's look at an example that doesn't work out. So here we have 6.5, 6.5, and 14.5. Okay, so again, I'm going to go ahead and color code these just so they're easier to follow in the notes. And we're going to write out our three equations again. So we're going to start off. We have 6.5 plus 6.5. And we have 6.5 plus 14.5. And didn't get those colors on there. And then we have 14.5 plus 6.5. Now you're going to notice on here that two of these are actually exactly the same thing. These last two here, exactly the same. And that's okay. They're going to work out the same way both times, so it shouldn't be a lot of extra work. That just happens because we have two numbers that are repeated. Okay, so when we do 6.5 plus 6.5, we get 13. Okay, and that was this side and this side, right? So 6.5 and 6.5 is 13. That means we want to know, is it bigger than this side? Is 13 bigger than 14.5? Okay, and the answer is no, it is not bigger than 14.5. Okay, and so at this point, you would just be able to stop and say, no, these do not form a triangle. Okay, and that's just the reason why it's really important that you check all three of them, because if you had just started down here with 6.5 plus 14.5, you would have gotten that those two equal 21, okay, and the third side that we hadn't used on that one is 6.5, and that's true whether you are doing it in this problem or if you had done it in this problem. Okay. Both of those are going to be bigger than 6.5. And so both of these look like they work out. It's only this one equation out of the three that doesn't work out. So it's really important that you check all three of those. Okay. In class on Monday at the beginning, we'll also talk about how you can use these to find the range of side measurements that you would possibly have for the third side. So in other words, if they tell you this side is 6 and this side is 5, what range would this side be able to fall into? And so we'll talk about that on Monday. And I hope that you have had a lovely weekend. Thank you very much, and I will see you later.